Alright guys, this is your final volume lesson. When you're done with this activity today, you'll take a little quiz. And this is the hardest part about volume, but hopefully you saw last week how easy it is. And once you kind of understand what it is we're doing today, you'll see that it's really just the same stuff you've already been doing, but you just have to do it twice for one shape. So we are doing composite solid figures, which basically is just a fancy way of saying we're no longer working with just plain old rectangular prisms, which are perfect in shape. This time you're going to have shapes that have kind of two rectangular prisms sort of smushed together. So it says a composite solid can be made by putting together two or more rectangular prisms. To find the volume of such a composite solid, you're basically going to divide it into two individual prisms, kind of like they've done in the second picture down here. And then we're still going to find the volume of each one, and then basically you just add them together. So really all it is, you're still finding the volume of the entire shape, but the way you're doing it is by cutting that shape into two pieces. I like to think of this as two cereal boxes sort of taped together. We could then untape the cereal boxes and find the volume of both, okay? The hardest part of this, though, is that sometimes there's something that's not fully labeled, so you have to do a little detective work to figure out what it is. So let's look at this one as an example again. In this composite figure right here, I'm going to start to look at this one because they've already chopped it up a little bit for me. So this time, rather than thinking about this as one solid figure, I'm going to think of it as two solid figures sort of attached together at the hip here. So I've got 9 inches tall, and it's telling me that this right here is 3 inches wide, which is perfect. I'm going to need to remember that. But it's not telling me how wide this line is right here. But because I have this entire other shape, and I can see that they meet perfectly, I actually know that this measurement is the exact same as this measurement right here. So this would be considered to be 5 inches. So that tells me my first cereal box right here is going to be 9 by 5 by 3. Okay, so again, same as you've done before, not too hard. 9 times 5 is 45, and then you just maybe need to do 45 times 3 off to the side. 3 times 5 is 15, 3 times 4 is 12, plus 1 is 13. So this would be 135 cubic inches for this blue cereal box. Now, for the second cereal box, I again have to do just a tiny little bit of detective work. I got to be careful. So I know that it's 3 inches tall. I know that it's 5 inches wide, so I'll put those in there, 3 by 5. But then right here, this was originally 15 inches, but it's no longer 15 inches. So I have to figure out how much I've already used, and that's going to be this total right here. So that means that this is actually, instead of being 15 inches, it's going to be 3 inches right here and 12 inches right here, because 3 and 12 would equal 15. So again, basically what I did is I just saw that this width is this width right here, which means out of this 15, I've already measured out this 3 right here. So that's going to leave me left over with 12. Now, before I multiply this one, 5 times 12 is actually pretty easy. That's 60. And then 60 times 3 would be 180. So I know that this blue prism was 135 cubic inches. This blue prism was 180 cubic inches. And now when I add those two together, I'm going, oops, that's not what you do. 135 plus 180 would altogether leave me with 315 cubic inches for that entire first shape. So not necessarily hard, it's just an extra step or two, which could make it a little bit tricky. So let's look at number 2. It says find the volume of a blue rectangular prism first. So we know that this bottom measurement is 15 inches across, so that's going to be one of our measurements. Then it tells us 5 inches, and then it also tells us 3 inches. So I've got to do 15 times 5 times 3. Well, I'm just going to do 5 times 3, which is 15, and then I'm going to multiply these two 15s together. 5 times 5 is 25. 5 times 1 is 5, plus 2 is 7. Bring down my place value holder, cross that guy out. 1 times 5 is 5, and then 1 times 1 is 1. So now when I add that together, I get 225. So this first one is 225 cubic inches, right? Now on this one, I have to be careful again. They're telling me that this entire measurement is 9 inches, but I've already used up this part, which they told me was 3 inches. So you see how this height is the same as this height. So if this side was 3, that actually means that this isn't 9, this is 6, because 3 and 6 add up together to be 9. So this tall length right here is 6. Then I've got the 3 inches like they stated over there, and then this 5 inches will be the same as this 5 inches. So I've got 5 again. Okay, so 3 times 5 is 15, and then I'm just going to do 15 times 6. 6 times 5 is 30. 6 times 1 is 6 plus 3 is 9. So that will be 90 right there. And now when I add these two together, 225 plus 90 is also 315. So here's the deal. I think you probably didn't even recognize it, but these two shapes were exactly the same. I just cut them in different spots. So I still come up with the same answer. It's just that you cut them up in different spots. Okay? So we're skipping number 3 because that's kind of what we just talked about. And now I want to come down here to number 5. It says find the volume of each composite solid figure. Same thing as before, but we get to decide this time where we're going to cut it. Now, you can't cut it like this because you don't know how to do the volume of a non-rectangular prism. So that's why we can't cut it there. But what I can do is cut it to make, oops, that's not what I meant to do, sorry. Is to cut it either along this side or I can cut it along that side. It doesn't actually matter. So let's just go ahead and do it like this. Why not? So I'm going to cut mine along this line right here, which means I'm going to figure out this rectangular prism first. Okay? And you have to remember that it's a whole rectangle, even though it doesn't look like it based on the way that I just drew it. So this is telling me that it's 16 inches tall. That's one of my measurements. I also know that it's 6 inches wide. That's one of my measurements. And then this is the last one that I have to solve right here. But this 8 is going to be the same as this 8 right there. I don't know about you guys, but this one's playing some weird mind tricks with me. It keeps like dipping in and then dipping out. That's weird. Okay, so again, not necessarily hard math. It's just you have to do some extra steps of multiplication here. So I'm going to do 16 times 6 first. 8 times 6, actually I'm not. I'm going to do 16. 6 times 8 is 48, so I only have to do one multiplication problem. Okay, so now 8 times 6 is 48. Carry my 4. 8 times 1 is 8, plus 4 is 12. Bring down my 0, and then cross out the 4. 4 times 6 is 24. 4 times 1 is 4, plus 2 is 6. Add those two together, and I get 768. So that's my first measurement. And now for my second measurement, I need to solve for this rectangular prism right here. So this is where I have to be careful. This isn't actually 24 because I chopped part of it off. And the part that I chopped off was actually 6 little centimeters right here. So what's 6 centimeters less than 24? That means that this side is actually 18 centimeters. And now I know everything else. This is 18, this is 8, and this is 6. So it'll be 18 times 6 times 8. So same as before, 6 times 8 is 48. Ooh, actually, no, I'm still going to do this. Okay, sorry. 18 times 48 is what I'm going to try to solve there. I'm actually going to solve it over here because I'm out of room. 18 times 48. 8 times 8 is 64. 8 times 1 is 8, plus 6 is 14. 4 times 8 is 32. Carry my 3. And then 4 times 1 is 4, plus 3 is 7. So then I would add these two together, and I get 864. So now here's the final thing that you have to do. You have to add together your two measurements. 8 plus 4 is 12. 6 plus 6 is 12, plus 1 is 13. Carry the 1. 8 plus 7 is 15, plus 1 is 16. So that means the entire volume all together is 1,632 cubic centimeters. Now, I'm going to make your guys' day a little bit. When you go to do practice on the rest of these problems today, use a calculator. I don't care. I just want you to understand how to do the volume, so it's okay to actually use a calculator. Although you'll see on the next one, it should be pretty easy math, okay? So let's look at number 5 real quick. I'm going to make a suggestion to you. The best thing that you're going to want to do is actually to cut it right here, and then that's going to make your life pretty easy. Okay, so let's figure out the volume first of this little guy on the top. He's 4 feet wide, he's 2 feet tall, and then this is my mystery number, but if I come down here, I can see that it's 5. So the volume of my first one is 4 times 2 times 5. Well, 4 times 2 is 8. And then 8 times 5 is 40. So the volume of this little guy is 40 cubic feet. And then on this one, it would be 3 times 14 times 5, Well, I know that 14 times 3 is actually 42. And then 42 times 5, I told you you could use a calculator, but I'm just going to solve this real quick, is 210. So that means that I would add together 40 and 210, and my volume altogether would be 250 cubic feet. Now I'm moving a little fast because I know I'm not going to have time for the rest of these. So I do have some real world problems for you that relate to volume, because volume is something that we do use in the real world. For example, that Boeing building that we have in Everett, it used to be one of the biggest buildings in the entire world. It's no longer, but that was something that somebody found out what the volume of that building was, because we needed to know how many airplanes you could fit inside of it. So these real world problems are going to be awesome practice. And here's what I'm actually going to do. I'm going to beg, actually, the only reason I'm changing my mind is because I'm remembering that what I actually told you to do at the end of this video was that you could go and take your quiz. So instead, I'm just going to choose one. We're going to do one together, and we're going to call it good, and it's all totally fine. Gosh, those two are scary. Let's just do number 6. It says, this building consists of 2 rectangular prisms, a small space for offices, and a detached larger space for warehouse storage. How much space does the building take up? So basically we need to figure out the volume for the big guy, volume for the little guy. So the volume for the big guy, let's just get the hard one out of the way first. So it's telling me that it's 12 meters tall, it's 50 meters wide, and it's 30 meters in length. So that's just going to be 12 times 50 times 30. Now I told you you could use a calculator, so I'm going to get my calculator out because I just want to save us some time here. So 12 times 50 would have been 600. And then 600 times 30, hopefully you found that pretty easily, is 18,000 cubic meters. And then for this little guy, they told you that he is 15 meters wide, 10 meters in width, and then 5 meters in height. So that's just going to be 5 by 15 by 10. And if we were to solve that, 5 by 15 by 10, that should be 750 cubic meters altogether. So then if we were to add those two up, we'd get 18,750 cubic meters. Okay? And that would be how you label that guy. So like I said, I give you permission to skip 7, 8, and 9 just because the activity that I want you to do today is I want you to complete your second Unit 8 quiz. All right? You actually don't have any composite figures on there, so it should just be volume equals length times width times height. All right? Ooh, also, don't forget your label could be something like cubic feet, could be feet cubed, or it could be cubic feet, something like that. So make sure you label your problems correctly as well. Okay? All right, good luck.